I know that's sad. I should be, I have to somehow figure out how to get you guys excited because, last lesson, it's a bummer, but oh well, it's the way it goes. All good things have to come to an end. Look on the bright side. You have a whole year next year of Algebra 1. Woohoo! Awesome. It's great. All right. And if I get a chance somehow to work during the summer and not have a zillion other things to do around here, I'll have notes for you all the way through. So, but that's a big if because my schedule's already busy in the summer. But we'll see. We'll see what happens. All right. Graphing linear functions. All right. First off, a linear function is one where simplistically the graph is a line, and you should see the word line in linear, right? So a linear function is one where the graph is a line. As you get further and further up in your math, you'll recognize characteristics of a linear equation. Here is a normal example of a linear equation. It would go something like this, and use your color here. Put a blue 3, then take your red and go with the red X, and then back to blue. Let's go like -5. Take your green and put a Y, then go back to blue, and I don't know, let's make it a 10. If you were to graph that, you would get a line. Now, I know that's linear. It's a little hard for you guys to determine that. And you might ask, well, how do I know that it is? Well, there's a couple things. The thing that makes it linear is the exponents of the variables. So somebody raise your hand. What's the exponent of the x and what's the exponent of the y? What's the value of the exponent for the x and the exponent for the y? What's the value? Kirsten? It is 1. We usually don't show ones, right? But the x has a 1 exponent and the y has a 1 exponent. That fact makes it linear. The fact that there are 2 different kinds of variables, an x and a y, makes it a function. So it's linear because the x is to the first power and the y is to the first power. The variables are to the first power. It is a function because there are 2 different variables. And there's a little situation where you got to be careful, but for your general purposes, that's the idea, and that makes it linear. Now, again, you're not going to have to recognize them this year. As we get further on, you will. Don't put this in your notes. We've done some situations where a variable would be squared, right? That would no longer be linear, and its graph is not a line. Its graph is actually what's called a parabola. Parabolas are U-shaped. It's real easy to show you a parabola, although Cole, sorry, you're not going to be able to see this because I'm tossing a ball. Ready, John? Yeah, just sit down. All right, here you go. Watch the path of the ball. Try to arc it to me, John. Just throw it up and, yeah. Okay? So again, I'm going to do Kyle. It'll be a little bit tighter. You see that U shape? Good, Kyle. Up and down to me. Thanks, buddy. Right? Can you see the U shape going? Right? You see that U? That's a parabola. And a perfect parabola. That equation would have an x squared and a y to the first power. You don't need to do this, but if I had something like this, that would be what's called a hyperbola with the x squared and the y squared. If I had an x squared and a y squared and I had a plus sign between them, it would be an ellipse. You guys know what an ellipse is, an oval. If they both had a 5 in front, and they were both x squared, a plus sign, and y squared, it would be a circle, would be the graph of that. So all kinds of things. Again, that comes later on down the road. The linear, the x variables to the first power, y variables to the first power. and there are two different variables. That makes it linear. All right. Every point on the line is another set of coordinates, parentheses x, comma, and then I'm going to take my green for the y. It's another set of xy values that solve the equation. Every point of the line is another set of xy values that solve the equation. Another set of xy values that solve the equation. All right, so, for example, I've got a line here to the right, and you can see it on your graph there. And I've highlighted some points here. So let's take a look at this first point right here, right? See that bottom point? All right, that bottom point has an x coordinate of 0 and a y coordinate of -3. Go ahead and take your red there and put a red 0 in for the x. All right, so watch the screen here. Let me try to show you what we're doing. Here's the original function right there. What we're going to do is we're going to find out what girl is going with guy 0. Now, I've already showed you it's 0, -3. But I'm showing you how you'd find out if you didn't know -3 was with guy 0. You would put in the 0 for x and solve the little equation. 2 times 0 is 0. 0 minus 3 is -3. And you would get a -3. So that's where that point came from. The 0, -3 point. What about guy 1? Well, I've already showed you that guy 1 is with girl -1. But again, if you put now 1 in for the x and solve for the y value. 2 times 1 is 2. 2 positives and 3 negatives leaves you 1 negative. And guy 1 is dating girl -1. Go to guy 2. Stick a 2 in. 2 times 2 is 4. 4 minus 3 is 1. And guy 2 is dating girl 1. And that's that third point there on your graph, right? Right here. Guy 3, stick him in there. 2 times 3 is 6. 6 minus 3 is 3. And we got guy 3 dating girl 3. Another match made in heaven. And that's that point right there. And the last guy I have here is guy 4. 2 times 4 is 8. 8 minus 3 is 5. And guy 4 is dating girl 5. And that's that last point right there. Notice all the points are in a line. And notice that we connected the points with a line and we put arrows on both sides. Some students don't want to put arrows. What does the arrow represent? What does the arrow mean? What does the arrow mean? Somebody raise their hand. What does the arrow mean? Abby? It goes forever in the direction of the arrow. So that bottom arrowhead says it goes forever down there, and this top arrowhead says it goes forever up there, forever, and ever, and ever. Amen. All right, it goes on forever. And please understand that the line represents every XY pair. Now look, we only showed you what, 5, 1, 2, 3, 4, 5 of the pairs. But do you know there are an infinite number of pairs? There are an infinite number of pairs. We can do some that aren't so easy to figure out. What about this guy right here, guy 1.5? According to the graph, what girl is guy 1.5 dating? Look at your graph. Let me see if I can get that. Look at your graph. There's guy 1/2. What is the y coordinate of that point, Nick? It is 0. Guy 1.5 is dating girl 0. You don't need to put this in your notes. Let me show you this. Guy 1.5. Would you agree that that's 3/2? Is 3/2 1.5? We got everybody okay with that? 3/2 is 1.5. Do we have life out there? Everyone all right with that? Okay. If you were to solve this little equation, would you not divide out the 2's, right? The front 2 is in the top. The red 2 is in the bottom. They divide out. What are you left with? What's 3 minus 3? 0. See, guy 3/2 was dating girl 0. Here, I found it out mathematically. Here, I found it out by looking on the graph and seeing what the y-coordinate was of that guy. You can do it both ways. So I found it out mathematically versus on the graph. You can do that with any point. Here's another guy. What's that guy? Guy 2.5. What girl is guy 2.5 dating? Well, look at your sheets. You got to write. You can't read it off the screen. Look at your sheet. What girl is guy 2.5 dating? Andrew? You're trying to find the y-coordinate of that point. So what you're after. So what do you think is the y-coordinate of that point? If you're not sure, you can say you're not sure. It's okay. Okay, that's fine. Devin, what's the y-coordinate of that point? Okay, so guys, let's go back a second. All right, let's take a time out. That's why if you're not following me here, then you're not going to follow me on some other things. So let's go back to the beginning. Just take a second, and let's go back and talk about ordered pairs. Okay, John, can you get that door for us? Hey, remember, we started off this whole chapter with talking about ordered pairs. And so, if you remember, I said, let's do the point 5, 2 and call it A. And you went 5 to the right and 2 up, and you put point A. And we did -3, -2, etc. Now, we also named the points that were there. Can you still name the coordinates of point Q? Hopefully that's big enough for you guys to see. Somebody raise their hand and tell me the coordinates of point 2. Andrew? Correct. Right? The guy is 2 and the girl is 3. We did point P down here. Somebody tell me the coordinates of point P. Everybody thinking now. You guys got to be thinking. You got to be thinking. You got to be thinking. You got to be thinking. Devin? 2, -4. Okay, remember that? So any given point, you from the graph can figure out what x point it goes to on the x-axis and what y point it goes on the y-axis. Okay, so now take that into what we were talking about a minute ago. If I can ever get back there. Where are you? Uh-oh, Cole just saw the quiz. Oh, well, Cole, there you go, buddy. All right, so we are, let's get this higher. We are right here, right? That's the point we're at. Isn't that guy 2.5? Between 2 and 3, right? This point right here is 2.5, halfway between the 2 and the 3. So now, looking at that, what girl is guy 2.5 dating? How many think they know? I'm not going to call on you. How many think they know? Can't you just do what you just did a minute ago? Okay, again, look, here's the point. What was the x value? This was 2.5. What's the y value? That's what we're asking. All right, on 3, if you got it, give it to me on 3. 1, 2, 3. 2, right? This guy is dating girl 2. The x coordinate's 2.5. The y coordinate is 2. Okay, so look. If I did it mathematically, I'd take the function and I'd put the guy in for the guy spot, the x spot. 2.5 is 5/2. Can you handle that? I hope you can. 5/2, 2.5. Again, I can divide out my 2's. What's 5 minus 3? 2. Who is guy 5.5 dating? Girl 2. Look, you can have fractions. You can have decimals. I can't tell you this guy right here. I'm going to go up here. I'll circle them in black. I can't tell you that guy's X value because it's hard to read. What is it, 3.2, 3.3, 3.1, 3.17? It's hard to read, right? But there is a guy there. Now, the girl is hard to read too. She's off over here. Is that 3.4? I don't know. 3.47? I don't know. But I know it's somewhere around 3.4. But remember, the line is made up of points. Look, there's a point here and one after it, one here and one here and one here, a point here, a point here, a point here, point here, point there, point there, point there. This is a point, here's a point, here's a point, here's a point, another point, another point, another point, another point, another point, another one, another one, another one, and they're all pairs. There's an infinite number of them. We only show a few and draw the line, and the line represents all of them. That's why we draw the line. The line represents all the guy-girl pairs, all the ordered pairs. Okay. So that's the idea, that's the concept. All right, let's go through and look at a couple other things here. C says to verify if a point is a solution, meaning is it a point on the line? What you have to do is, I'm going to take my blue and write substitute. Substitute in its coordinates to see if they solve the equation. I wonder what that means, solve the equation. All right, well, don't miss this. This is a key concept. What we mean by solve the equation is we mean that when you put in the coordinates, the left side ends up equaling the right side. Left side equals the right side. The left side equals the right side. All right, let me get the shade out of the way so I can get this higher for you guys. The left side equals the right side. So we have two examples. In the first example, we say, is the point negative 1, 4 a solution to y equals negative 2x plus 2? All right, don't forget the pair is ordered, right? Who comes first, x or y? X. So the negative 1 is the x, and the 4 is his girlfriend. And so when you substitute, I'm going to use my color in the first one. Where the y is, I'm going to put in the 4. You can put it in a parentheses if you want. I'm definitely going to use a parentheses for the x, because the x is multiplied times the negative 2. So in parentheses, I'm going to put in that negative 1. So let me give you time to catch up. So I have 4 equals negative 2 times negative 1 plus 2. Do you guys get what I did? I just put the y in for the y and the x in for the x. Okay, I'm subbing in the values. If indeed negative 1, 4 is a point on this line, then we're going to get a true equation. The left side will equal the right side. If it's not a point on the line, and by the way, there are lots of points not on the line, right? Look at the original question. Is that point a point on the line? No. If you put its coordinates into the equation, it won't be true. Is that a point on the line? No. If you put its coordinates in, you won't get a true equation. You can even get close. Is that a point on the line? No. If you put in its coordinates, you will not get a true equation. However, any point on the line, you will get a true equation. And so let's finish it off. All right, so 4 is a 4. Negative 2 times negative 1 is a positive 2. And lo and behold, the left side equals the right side, and therefore we would say, yes, it is a point on the line. Why? Because 4 equals 4. If when you sub in the values, the left side equals the right side, guaranteed or your money back, it's a point on the line. Don't do this for time's sake. What if we took that same guy and see if he's dating another girl, 6? Well, look what would happen. Again, you don't need to do this in your notes. I'll just do it. Let's look and see what would happen if we did that. So it's girl 6, right? And it's guy -1. And you should already be saying, well, of course it's not going to work. It worked when the y was a 4. Yeah, 4. So, 6. 2 plus 2. Does 6 equal 4? No. No, that's not a point on the line. You might say, but the x was on the line. Yeah, let me go back to the example. I got so many circles now. Let's take this circle right here, right? The guy is 2, and the girl is 1, right? Well, it's not this point up here. That's still guy 2, but that's girl 4. It's not on the line. It's only one that was on the line. And so that's what we found here, the -1, 4. Okay, so go ahead and try 2 yourself. Go ahead and try it. Sub in the values. Answer the question. Is 8 -14 a solution to the function? Meaning, is it a point on the line? Jack, do you have a question or the answer? Don't want the answer. We just started. You were obviously doing it while I was explaining all the other things. I hope you listened to what I was explaining while you were going ahead. So is 8 -14 a solution? Your work should look like my work above. Be orderly. Once you're done, a yes/no answer to this question. If they equal, it's a yes. If they don't equal, it's a no. All right, if you're done on 3, give me your answer, yes or no. Here we go, 1, 2, 3. Yeah, and this one should be a no. The y is a -14. Be careful with those negatives. As I told you, if you'll always put a parentheses where the variable is, you'll be safe. So in this one, we end up with -14. 8 negatives and 2 positives leaves us 2 negatives, and that's a 14. And -14 does not equal -2, so no. This is not a solution, and it's not a point on the line. So for number 1, yes it is, and let's go back to number 1 in red and say it's a point on the line. Number 2 is not a solution, therefore it's not a point on the line. It's not a solution, and only solutions are points on the lines, so therefore it's not a point on the line. Jack. Just a negative sign is fine. You can put a -1 if you want to. It's going to be the same thing. A negative times a positive 8 is a -8. -1 times a positive 8 is still a -8. You can go either way with that. Remember, algebra doesn't show those ones. That was way back beginning of the year in pre-algebra when we started. Okay. Any other questions on that? Can you find out then whether... I could ask it 2 ways. I can ask it, does the point solve the equation? Or I could ask you, is the point a point on the line? I could ask it either way. You'd do it the exact same way. You follow? To find out if it's a solution, you got to sub in the values of the point, see if it's true. To find out if it's a point on the line, you have to sub in the values and see if it's true. Could ask it 2 different ways. Is it a solution? Is it a point on the line? They're one and the same. Things that are solutions are points on the line. All right, number 2. Number 2, to graph a line, you must know at least We're back to geometry. How many points determine the location of a line? Minimum amount of points. Pamela, 2 is the minimum amount. Now, don't put this on your graph, but I want to teach you a concept. What we're going to have to do to graph it is we're going to have to find the points so we know where to draw the line. That's what we're going to do. We find the points. If we find the points, we can draw the line through them. Pretty easy. That's how we're going to graph these lines. Now, look at the screen. Let's suppose I correctly found this first point. Don't worry, I didn't even look at the equation. I'm not even sure it solves it. But let's suppose it did. And let's suppose that was a correct point. And what if I chose a second point, but my second point was wrong? If I only choose 2 points, I'll always have a line to draw between them. But I won't necessarily know if I made a mistake. But here's what happens if you use an XY chart to find 3 points and connect them with a line. Here's what happens if you use 3 points. Let's suppose, again, don't write anything yet, I'm just trying to get you guys to think. Let's suppose your third point ended up right there. What do you have to conclude looking at those 3 points? There's only one thing that you can conclude, and you definitely have to conclude this looking at those 3 points. What can you conclude? Nick? I am definitely wrong because straight lines are straight. Either one of those points is wrong, 2 of those points are wrong, or all 3 of those points are wrong. So here's the point I'm trying to make. Listen now. If you only find 2 points, you'll never know if you made a mistake because there will always be a line that goes through them. However, if you find 3 points and they don't line up in a line, you know guaranteed you made a mistake somewhere calculating those points. And go back and take a look at your points. And that's why we always say plot 3 points. So, for example, this point should have been right there. Now they're in a line and we'd have been good to go. All right, and again, those are all fictitious. I'm just trying to make the point with you. Okay, so here's how these go. They give you a linear function. Notice the y is to the first power. You don't have to circle it. I'm just trying to get you focused. Notice the y is to the first power. Notice the x is to the first power. All right. And we have 2 different variables. To graph it, we make what's called an XY chart. We've done something similar. The difference here is they don't tell us the domain, do they? Do you remember a while back when we did problems when they didn't tell us the domain? Do you remember what we did? Does anybody remember? We did just a few of these. What did we do when they didn't tell us the domain? Jack? Nope. What do we use for x if they don't tell us? That's the question. What do we use for x if they don't tell us? All right, everybody got it? Listen to the question. What do we use for the x value if they don't tell us any x value? That's the question. Anybody have an answer? 1, you can. Let's get a better generic answer. So here's the question. What do you use for x when they don't tell you the domain values, right? Remember, domains are x's. What do you use for x if they don't give you any x values? Anybody else? How would you answer that question? Jordan? Nope. What do you use for x if they don't? Now, Madison's okay. She said 1. 1 works. I can use 1. What do you use for x if they don't give you the values of the domain? Nick? You can use 0. 0 works. 0 is a great one to use. 0 is nice and handy. 0 is always the first one I use. Matter of fact, I'm going to use my red. You can put 0 in there if you want, because 0 is real handy. But let's answer the question that answers everything. If they don't give you the domain, what do you use for x? Listen, this is an important question now. Ileana? Yeah, so the answer is anything your little old heart desires. You can use any value you want. I'll tell you this, though. If you use 100, do you want to draw an XY chart that goes all the way to 100? No, I don't want to either. Now, you could. Guy 100 is probably dating somebody. But we don't want to draw the XY chart that big. But you can use any value your little old heart desires. Anything. The best value is always 0, and I always start with 0. So let's use 0. Remember now, we got to find the value of y. So we're just solving this just like we did a minute ago. We're finding out what girl guy 0 is dating. Matter of fact, we could even do it in functional notation if we want. We could do f of 0 if we wanted to. If we really, really wanted to. But I don't want to confuse you guys. So we put the 0 in for the x. Negative 3 times 0 is... See, that's why 0 is beautiful. It makes that disappear. And what do we have left? Our y equals 5. All right. We found a pair. I'm going to use blue for my points. Can you plot 0, 5 on your Cartesian plane? Do you remember where to put 0, 5 on your Cartesian plane? 0, 5 on your Cartesian plane. Did you go right there? I hope, right? 0, 5. 5 on the y-axis. That's the point. It has 0 for the x and 5 for the y. Yes? Rattle, rattle. Are you with me? Do we have life out there? All right, point number 1. Let's go point number 2. Madison, what'd you say? 1's always nice and handy. He's usually pretty easy to deal with. So we're doing the exact same thing. We're writing the equation. We're putting a negative 1. I'm putting a positive 1 in for our x. Negative 3 times 1 is negative 3. What's a negative 3 and a positive 5? Positive 2. Now look, if you can't do that in your head, do the next step and work it out, all right? If you can't do it in your head, then do the next step. All right, plot the point 1, 2. Question, Raquel? So hopefully you went 1 to the right and 2 up, and you stick them right there, right? Now again, if we were correct in both points, we already know where the line is. The reason we're doing a third point is to be sure we're correct. So look, you could do negative 1. You could do a half if you want, but you guys love fractions, don't you? No. So we're not going to do a half. You could. You could do 0.3 if you wanted to, but that's hard to graph. You could do negative 1. You could do negative 5. You could do negative 1,000,000. But that'd be really hard to make a Cartesian plane. So what do you want to keep going? You want to just do boring number 2? All right, we'll just do boring old 2. Boy, 0, 1, and 2 always get the girls, I'll tell you. All right, so you stick 2 in there. Negative 3 times 2 is a negative 6. 6 negatives and 5 positives leaves you 1 negative, right? And if all's right in the world, this couple will fall right in line with everybody else. 2 to the right and 1 down. Look at that. Take your red. Draw a line. What are some of you going to forget to do when you draw your line? You're going to forget the arrowheads because you're not a detailed person, but maybe you'll get there one day. Now look, we only showed 3 of the infinite number of pairs. There's an infinite number of them. Infinity. Hey, guy 100. Can anybody figure out what girl he's dating? We started off saying we could use 100. It's not hard. What girl is guy 100 dating? John? Nope, not 50. Go for it, Lauren. Right? He's dating girl negative 295. You know what? If you keep following, look, keep following this arrow all the way until you get to guy 100 and go down, you'll get to negative 295 because that's who guy 100 is dating. You could do negative numbers. What if we did negative 10? What girl is negative 10 dating? Girl negative 10. Jack? Positive 35 is correct. Negative 3 times negative 10 is 30, right? 30 plus 5 is 35. If you went out here, watch. If you went out here to negative 10, you would go all the way up to 35 and you'd meet that line at 35. Because the line keeps going, right? And I drew it a little crooked there because I'm going fast, but that's the idea. All right, we need one more thing in our notes. Put a little asterisk underneath the use an XY chart and say, you choose any value for X. You choose any value for X. But class, what's the best value? 0 is always the best, and then try to stay small so you don't have to make a gigantic Cartesian plane. We'll talk a little bit more about it tomorrow, and then hopefully tomorrow in class you'll have time to get your homework done. I've only got, as you can see, a couple more examples, right?